Hello! In this video, we're going to talk about section 7.1. 7.1 is graphing linear inequalities in two variables. Let's begin. We start off with a definition of what a linear inequality is. You might already know this from previous work. A linear inequality is of the form ax plus by is less than c, where a, b, c are real numbers, and a and b both cannot be 0 at the same time. If they were both 0 at the same time, then you wouldn't have any variables. Notice you could use, for different inequalities, you could use less than or greater than. These are strict inequalities because they do not have an equal sign. Or you can have less than or equal to or greater than or equal to. These are going to be called non-strict. Less than or equal to means at most. And greater than or equal to means at least. So, back of Advil says you can have at most 4 pills a day. That means you can have 4 or less. Less than or equal to. At least, you must be at least this tall to ride a ride. That means you must be this tall or taller. Okay, now we're only going to do linear inequalities of 2 variables. If you have more than 2 variables, well, it'd be in 3-dimensional graph, and we don't know how to graph in 3D. So for this section and the next one, we're only in 2 dimensions. Later on, we learn what happens if you're in 3. So we'll be drawing pictures. So pictures will be essential in actually the first 3 sections of Chapter 7. So make sure you are extremely comfortable with what we're about to do a bunch of examples of it. In fact, the video you'll watch has 3 examples because it's a big deal. But to do that, you need to know the 3 steps in order to graph a linear inequality. The first one is to graph the associated line. If the line, if the inequality is strict, that should say inequality here. Inequality is strict, use a dotted line. You'll see what that means in a second. And then pick a test point not on the line. And if the coordinates of the test point satisfy the inequality, then shade the side of the line where that test point came from. Otherwise, shade the other side. Pause the video if you need to write all that down. I'm assuming you paused the video. Mazel tov. So I'm just going to make up an equation here. 5x minus 3y greater than or equal to 10. Make that up. Okay, so first off, we're going to graph the associated line, meaning ignoring the inequality. We're going to replace the inequality symbol with an equal symbol, no matter what type of inequality it was. And the way I suggest you graph this line is by finding x and y intercepts. That should work 99% of the time. To find an x-intercept, you pretend that y is equal to 0. So let me just do this. So if this is 0, if y is 0, that whole term is gone. So we can just ignore it. So then we would just have the equation 5x equals 10. And that means that x is 2. So we just found the x-intercept to be 2. And it's a good idea to label your points. So I'm just going to say 2, 0. All right, now we're going to do the same thing. I don't think I can erase that highlight, so I'll just have to use another one. So now we'll find the y-intercept by setting the x equal to 0. Well, if I set x equal to 0 and pick a color that's slightly darker than that one, then that would give us the equation. Oh, that's okay. That's fine. Let's get the equation negative 3y equals 10. So solving for y, I do get negative 10/3, or negative 3.3 repeating. So plotting the point negative 10/3, excuse me, 0, negative 10/3, 1, 2, 3, 4, so about right here. I would say 0, negative 10/3. So I have 2 points. 2 points make a line, so I will use a solid line. The reason solid is because it's barely there, but our inequality is non-strict. So we'll connect it with a solid line. So not only is it a good idea to label your points, definitely label the line. 5x minus 3y equals 10. Okay, I have to take my toy away from the dog because he is going crazy over here. Okay. All right, so now that we have the line 5x minus 3y equals 10, we did step 1. We graphed the associated line. Step 2, we'll pick a test point not on that line. So what just happened was, by graphing this line, we have separated true and false. We don't know what side of the line is true. We don't know what side of the line is false. So we pick a point. It doesn't matter what point you pick. Oh, this is sort of lopsided there. That's better. As long as you pick a point. It looks like Garth. The easiest point to pick is the origin, 0, 0. So I'm just marking this on the graph, 0, 0. Notice 0, 0 is above the line. Step 3, if the coordinates of the test point make the inequality true. All right. So what that means is we put 0 in for x and 0 in for y into the original inequality, and we ask ourselves, is this true or false? Is 5 times 0 minus 3 times 0 greater than or equal to 10? Well, the left-hand side is 0. Is 0 greater than or equal to 10? No. So we go to the latter part, shade the other side. So what just happened was we picked a point that's above the line. We just determined that point above the line is false. That point that we picked in red is a representation of all points above the line. All points above the line will make it false. And our job is to always shade the true side. So if all the points above the line are false, then where are the true points? They're below the line. Hooray. So that, in the red and the blue there, the red shading and the blue line would be your solution. I should have used the blue color, so I apologize. So all of this is your answer here, and I know I'm covering up what I just wrote for the coordinates, but that's okay. Make sure when you're doing this, you do not have wimpy shading. For instance, if this was the original graph and you just went, like you couldn't be bothered to shade, you did something wrong. Come on. It's gonna hurt you more. Please shade. I know you can't probably get colored pencils right now, but you can always order some on Amazon. Okay, so in the video, you're going to have 3 examples as mentioned. And one of the examples is going to have a region, when you're all done, that looks something like this. All right, I want to talk about the differences between the two here. The one on the left, notice, will keep growing forever and ever without bound. Like that shading will go forever and ever down and never stop. When a region does that, we call that unbounded. If a region is enclosed on all sides, meaning it doesn't go on forever, we call that bounded. So you'll see examples of bounded and unbounded in the next video that you'll watch. Okay. Regardless if it's unbounded or bounded, there are going to be very special points that we formally define in the next section, but we can talk about them now. And those points are called corner points. Before we get to that, let me say this real quick. Your region that you're doing the shading in, your final region, is called the feasible region. So to be clear, the red one on the left is an unbounded feasible region, and the blue one on the right is a bounded feasible region. Okay, surrounding the feasible region are boundary lines. Oh, is there an R here? Is it boundary or boundary? Oh no. I'm just gonna just put it in there So it sort of looks like there's an A, but I'm not sure, and I'm way too lazy to go look that up. Okay. A corner point occurs when you have the intersection of two boundary lines that touch the feasible region. So for instance, this line, let me get a different color. What do we got? Green. This line here is a boundary line. This line here is a boundary line. They intersect, let me make that black again. They intersect right here, and that point touches this region, so that point's considered a corner point. Same deal, this line here intersects this line here. They touch the region at this point. That's also a corner point. The red graph, how many corner points does it have? None. There's only one boundary line, and there's only one inequality. You can't have any. But it's not to say that if it's unbounded, you can't have a corner point. Like, for instance, if I made this graph, how many corner points are there? Hopefully you said 2. We have one that's a little obvious. This one here is the intersection of the two lines, and it touches the shaded region. But then you also have this one here. Sometimes the axis could be a line, and it's crossing this diagonal line going down here. So these guys are your corner points. Okay. So in the video that you will watch, maybe it's more than one. No, it's just one. The video you'll watch number... Oh, it is 2. Oh yeah, it's 2. You'll watch numbers 81 and 82. In videos number 81, you go from, in 81 you only have one inequality, so you'll have a graph similar to the red one. In 82 you'll have more than one inequality, so you'll have a graph similar to the blue one. And it goes through all 3 of these steps here: graph, test point, shade. Make sure if you have a bunch of inequalities, you graph the line, pick a test point, shade. Do not graph all the lines and then do all your shadings. That's ridiculous. It's going to be extremely hard to figure out where to shade if you don't do it as you go. All right, so watch 81, 82. That will actually end section 7.1. So the next video will be 7.2 and 7.3. All right, laters.